so that we can say we want to be sure that we're going in that interval. So we want to be sure we're in this interval and be sure we're in this interval. Because if we go outside the interval, then of course we're seeing what's happening on this side of that max or min, which is going to be the opposite of what we want. So it's about 1.1, which means that we can test x equals -1, and we can test x equals 1. First derivative test, plug it into the first derivative. So the first derivative test, that'll be positive, right? When you plug -1 in. And when you plug +1 in, it's going to be positive. So what is the second, so what do we know then? If the slope of the tangent line is positive on both sides of that number, what does it make that number? It's an inflection point. Or, this is to make it more generalized, it's an inflection point or it's a vertical asymptote. But we'd already know if it had a vertical asymptote. But you do have to kind of keep that in mind, is that sometimes that'll throw you off too. So now we know that where x equals 0, we have an inflection point. So we can graph this guy now. Do we want to graph it? I don't know. I don't have anywhere to graph it. So we've got a maximum at -√6/5. We've got an inflection point at 0, and when we plug 0 into the function, we get 0 out. And we've got a minimum at +√6/5. And to get the output values for those, to find out where the maximum and are, we need to plug it into the function, and it's an ugly number to plug into the function. So, yuck. Let's see what we get. Negative. Oops. Those 2 parts. Syntax error. Okay, I know. Let me go back and look at it and see why there's a stone. So this one is at 0.61. I guess that makes sense, since the inflection point's at 0, 0, it would kind of be a good assumption that the function is symmetrical. So we've got an inflection point at 0, 0. Got a maximum at -1.1, 0.61. And we've got a minimum at positive 1.1.
You have the signs backwards for F double prime.
For what?
For F double prime, when you calculated it, you have the signs backwards. The first one's positive, second.
Over there?
Yeah.
So Travis led me astray?
No, I agree with what he says.
So you're saying these signs are wrong?
Yeah, well, it's negative, it should be positive, what's positive, it should be negative.
I'm never gonna let you guys do computation again. Are you sure?
Yes, yeah, it works out that way.
All right, so if this is positive, we have a happy face here, and the minimum's there. And if this is negative, we have a sad face, so we have a maximum. Well, that looks like it's gonna be a little bit easier to graph then. What about the x-intercepts? Can we find the x-intercepts? I don't know, let's see if we can find the x-intercepts. You could always check and see if you can find the x-intercepts. The x-intercepts are where the output value of the function is 0. That part I know. Well, let's see, I can factor out an x cubed. How about a negative x cubed? And that leaves me with x squared minus 2. Yeah. And so negative x cubed equals 0 means that x equals 0. There's one of my x-intercepts, but I already have that one. And then I've got this guy, x minus square root 2 times x minus square root 2. Oh, you mean we have to do that now when we have a difference of squares? Yeah. Whoops. How about we change one of these to a plus so that it actually is a difference of squares? So we've got x-intercepts at x equals plus or minus 1.4. So we've got x-intercepts now. Right there. And right there. Whoops. Ta-da. And that's what it looks like. Ain't that party? Okay, so now what I want you to do is find the people who have the same number as you.
Oh, it's a group of like 3, 7. I should just move to the back then. Oh, get out of here. 3 is coming up here. You're 3.
Cut, once you're all together, come get a big piece of graph paper.
What? You're supposed to form the group with the same numbers. 3.
And I just left some of my stuff over there. Is that okay?
3?
3? Can you give us one, please?
Probably could have won.
Thank you. Thank you. Yeah. Go ahead. You're gonna.
I think what we did for that example, she
Could be
equation for us graphing.
kind of a weird number, you know?
Are you a 3 as well?
Yeah.
I don't have a marker, sorry.
So what do you think you're gonna do? You're gonna graph your function using second derivative test, or you may have to use the first derivative test too.
I can just pause this one until like we're learning anything.